Okay, so it seems like most of our questions are revolving around the word problems. So we'll tackle a few of these. Remember your strategies though, draw a picture. If they don't give you a picture, you gotta draw a picture. You might have to read the word problem 5 or 6 times to understand what the pictures that all look like. 37 is talking about a circular race car track. So that would have like an inner edge and an outer edge that's made up of pieces. This reminds me of anybody ever have those little stock car things that things pull on a lever and trigger it and make it spin out if we went too fast. Anyways, so that's what it looks like. There's 10 pieces. They look like this. They tell us that the inside edge of each piece, so that would be this little piece right here, is 3.4 inches shorter than the outside edge. That would be our outside edge here. So we're comparing those two edges. And they want us to find the width of the track. So it doesn't seem like they're giving us a whole lot of information. From what we talked about on Tuesday, what are we looking at here? We're talking about a distance around the curved edge. What is that word we call it? It's an arc. It's an arc length. We're dealing with arc lengths. So I'll be perfectly honest. I do not know how to tackle this at all right now. I'm a little dumbfounded, but let's see what we can do. I'm going to call this S1. Arc length, we use an S for arc length, right? We'll call this one S2. And what I know is that S1 is 3.4 inches shorter than S2. So I'm going to attempt to write an equation here. S1 is not equal to S2. S2 is longer, right? So I would have to add the 3.4 to S1 to make it equal to S2. Does that sound right to you guys? I'm never quite sure where to put the plus when I have like something's longer or shorter. I think this will be shorter. So S1 plus 3.4 is S2. Cool. What else do we know? Okay, if we're talking arc length, it might be helpful for us to also think about radii. So we would have a radius to the inner arc that would be a little bit short. I'm going to call that one R1 because that will go with that S1, correct? We've got a radius to the outer arc that would be R1. Call that R2. I don't know if this is going to help me at all, but whatever. R1 and R2. Actually, that should be helpful, right? Because if I knew those two values, they're asking us for the width of the track. I should be able to subtract those two things, and that would, whatever the difference is how wide the track is. So I know what I'm looking for is whatever R2 minus R1 is. That's going to give me my answer. You guys with me so far? Still have no idea how this is going to play out, but we're making some headway, I feel like. Thinking through my equation, S equals R theta. We haven't talked about angles at all. For each of these pieces, could we get an angle for it? I think we could, couldn't we? Because we know how many they are. We're going to assume they're all the same size, right? Now, if we're going to use S equals R theta, you guys remember the big key thing about this equation? What has to be true about theta? It has to be in radians, right? So I'm going to figure out how big each of these pieces is, how big the angle is for each of these pieces in radians. How many radians is it all the way around the track? So all the way around is 2 pi, right? But we're chopping it up into 10 equal angles, right? So I'm going to say that the theta for both of these is going to be 2 pi over 10. And let's simplify that for pi. So far, so good. Okay. What to do from here? Try to find all the spreadsheet. So. All right, well, let's start playing with this formula. Maybe we'll write 2 different versions, one for our inner and one for our outer. I can't really think of anything else to do. So I know theta is pi over 5, So S1, I call, well, S1 equals R1 times theta, which we know is pi over 5. And S2 is equal to R2 times, well, also pi over. Ideas?
Could we do one for the other?
We do have an equivalence for S2, so do you think about putting this into for S?
Yeah.
For this one?
Yeah. Or like, yeah.
In place of S2, substitute, or did you have something else in mind?
Or we could use like that. R1 times pi over 5 equals S1. Then R1 times 5 plus.
Oh, you want to substitute these in there? That's a good idea. I like that. Okay. So let me bring this down here. This is S1 plus 3.4 S2. So we're going to substitute in place of S1 and S2. Yeah, let's give it a shot. So R1 times pi over 5 plus 3.4 equals R2 times pi over 5. You know what I really like about this equation right here? It's got R1 and R2 in it. And we are literally looking for the difference between them. In fact, I'm kind of thinking maybe we can manipulate this equation so that one side of it looks like this. And that might get us an answer. Not 100% sure, but let's give it a shot. So do you guys understand why this is going to be my answer? The width of the track would be the difference between the two radius, the inside and the outside. So I know this is going to be the answer. So what I'm suggesting doing is instead of finding both of these, what if we just make this equation look like this on one side, and maybe the other side will be some numerical value, just magically be our answer. So let's try. So I'm going to get them both on the same side of the equation. I want R2 minus R1, so maybe I'll leave this alone. Leave the 3.4 here, and I'll subtract this. So this is R2 times pi over 5 minus, ooh, this is looking really good to me right now. Because I got my R2 minus my R1. You guys see that okay? And pi over 5 that they have in common, we could factor that out, and we would have R2 minus R1, right? Let's do that. 3.4 equals pi over 5 times R2 minus R1. Well, this is going to be beautiful. Yeah, just solve this. Divide by pi over 5 on both sides, which would be the same as multiplying by its reciprocal. So that's my answer there. Do they want decimals? I think so. Say specifically, but so I could type this into my calculator and get a decimal. If they want an exact answer, 5 times 3.4 would be, what's that? 5 times 3.4 would be 17. Yes, I got a calculator. Pretty sure it's 17 over pi is going to be my exact answer. Are you looking up the answer in the back of the book?
Yeah.
So did they give a decimal?
Yeah. So
5.4. Yep. Sweet. Hey, it worked out. This is kind of surprising because this solution, and there's probably other ways to do it. We didn't actually have to figure out what any of the radii were. We never actually figured out what either of the arguments were. So the strategy I used here, I took notes, and then I thought about, I kind of worked backwards. What is the width of the track? I kind of thought, like, how am I going to find the width of the track? That's going to be R2 minus R1. And that was kind of the key to it. Because once we did our substitution and I saw R2 and R1 in the same equation, I was like, oh, maybe we can make this happen. So, all right. Questions? Are we feeling okay about that one now? That's a cool problem. I like that a lot. Thanks for asking about that. Okay, 35. We got a circular disc. We're gonna cut a. We're gonna cut off a 10-degree wedge. They want a perimeter. So this is exaggerated. That's way bigger than 10 degrees. They did tell us that the radius was 11 inches. So 11 inches here too. So basically I need to figure out my radius or my perimeter, which is going to consist of 2 straight segments, both are 11, and 1 curved piece, this arc, where I need to find that work. So to finish this up, you just need to do 11 plus 11 plus whatever that S is, whatever that arc length is. And how are you going to find that arc length? You're going to use your formula. S equals R theta. You're going to have to convert 10 degrees into radians to get that to work. But you've got the radius, you've got the angle, you've got all the pieces you need to do it. Okay, so I'm leaving that to you. And any questions on how to finish it?
Yeah, well, I think I fit them.
Did you convert 10 degrees into radians?
Yeah. That'd be 5 over 8.
Pi over 18 is going to be, yes, this theta. So S equals 11 times that. So S is 11 pi over 18. So my final perimeter then would be 22 plus that. And that's not coming out right. Did you forget the 22 part? Okay. Because they're asking for the whole perimeter, just the arc. So you had to, so we've got to add this piece and this piece on. They gave us the radius was 11. So if I cut this wedge out, it does have kind of 3 sides, if you will, although this isn't really a side, it's a curve. And these 2 sides would be 11 because that's the radius. So if you're off by 22, then you did the hard part, right? You're just missing a couple pieces of your wedge. I think, yeah, so to the nearest inch, find the perimeter of the 10-degree sector.
Okay.
Sector is like a slice of pizza, slice of pie. All right, 13. 71.72 degrees in the radians. We are just going to use our conversion canceling. So 71.72 degrees. Multiply it. I want to cancel degrees. I want to turn it into radians. There's 180 degrees in pi radians. And that gives us 71.7 pi over 180 if we're looking for an exact answer. That is not an acceptable answer because we don't put fractions inside of fractions in this class. Okay, so you may not leave an answer like that. The decimal is a fraction, right? So give me a fancy version of 1 I could multiply this by so I wouldn't have a decimal anymore. What could I multiply 71.7 by so that there were no more decimals? How about 10, right? 10 over 10, agreed? That is 717 pi over 1,800. And I have my doubts that this is going to simplify, but we'll let the calculator give the final say here. 717 over 1,800. I'm leaving the pi out because I just want to simplify the fraction. Oh. Math bracket. Oh, it does simplify. Cool. 239 pi over 6. Oh, you know what though? I left off a digit. Whoopsie. Take that back. I left off my 2. My bad. So this is the 2. So I'm not going to multiply by 10 over 10. What am I going to multiply by? 100 over 100. So this is not 717. It's 7,172. This is that. Okay. Not bad. Hang on. 7172. 1,000. Yeah, that's it. Does that look correct? Is that what you're seeing in the back? You guys are checking your answers, right? We've had this discussion many, many times. If anybody's lost their paperclip, let me know. Check your answer, every problem. Okay. 43. This is the one with the 2 boats. Yes. Sure. Thank you. Like, leave this as your final answer, kind of. So if I submit approximate an answer to the thousandth place, yeah, that's how you do it. But if I ask for an exact answer, then I need you to come up with a fraction. Actually, you bring up a good point, though. If I did this without, I'm curious what would happen if I did this without the pi and just math fracted from here. Just let the calculator deal with the decimal. Do you think we'll get the same answer? Is the calculator that smart? What do you think? Ooh, that's even better. Oh, I didn't type it in right. Yeah, same answer. So I didn't even need to really do this extra work here. I could have just let the calculator convert this straight into this. So leave the pi out of it. If you're looking for exact answers, yes, type it in your calculator. Leave the pi out of it and then stick the pi on it. Yeah. Yes. Did they? Okay. This is number 13. And then let me reread my instructions. Yes, it's convert from degrees median or degrees minutes seconds to radians. So they weren't specific. So if you gave decimal answer or something like that. Now, could you do this though? I asked you for an exact answer. On the test, I will ask for an exact answer. And I'll give you most of the points if you give me 1.252, but not all. Okay. All right, moving on to 43. These are our 2 boats that we're heading out to sea on slightly different courses. And the question, I believe, is asking how far apart from each other they are. Does that sound right? So I'm looking at this and I see a isosceles triangle is what I see. And I'm thinking maybe make a right triangle out of it. A couple right triangles. I don't know what you think. So if I'm looking at that right triangle, I'm going to do the top one there. Looks like this. And this is 25. And if I could figure out what that side is, then I could just double that. That should give me an answer. How do we feel about right triangle trig? That's half of our topic for today. Yes? No? We're going to do a whirlwind review of it. So, but now's a good time to start. What I do need to know is this angle here. And I should be able to figure out by just subtracting these 2 things. So let's get these as a decimal. Are you guys feeling pretty confident turning degrees, minutes, seconds into just degrees as a decimal? I'm not showing my work here. You guys are right with that. Well, you can look at the calculator. That's 52 plus 12 over 60, right? That's 52.2. And this one is 42, 30 minutes. That's half a degree, right? 60 minutes in a degree. So this is just 42.5. So I should be able to subtract those 2 things and come up with this big angle right here. So 52.2 minus 42.5, 9.7 for that big angle here. And this is half of that. So this angle right here is 4.85 degrees. Feeling all right? All right, I need everybody's undivided attention here because we're gonna start reviewing right now. We're gonna do some more examples here in a minute. Do you remember the little cheat code that we use for right triangle trig that tells you how to do sine, cosine, and tangent? SOHCAHTOA. You guys remember that thing? I know that the first time you saw this, it was an ingenuity. It was not the greatest of things, but I will tell you this: we were talking about this yesterday after school. Of all the stuff in ingenuity and geometry, the trig unit was actually pretty decent. Like, it was thorough, and the examples and the lessons in it were good. Now I think a lot of you by that point in the year have kind of just like done the like glazed over, and maybe you were like getting 100% on all of your quizzes, but like, you know what I mean? So if that's the case, then you might have some catching up to do here in the next couple days, I guess. You should have some familiarity with how to solve right triangles. Now, I don't expect you guys to know anything about log sines or log cosines. I don't even think they got to that unless the Algebra 2 classes last year. We'll start fresh on that. But I do expect you have some familiarity with how to solve a triangle like this. And if you don't, this is going to be one of those things that you're going to have to get caught up on. I'll gladly help you, but we're not going to have time in class to spend a week doing this. We're going to spend half a period today. All right, and it begins right now. So here we go. All right, first thing you do is you label your sides. You guys remember how to do hypotenuse, opposite, and adjacent? Let's do that. The hypotenuse is always across from the 90-degree angle. The opposite side is going to be the leg that's across from the angle that we're dealing with. So it's going to be our x in this case. And the adjacent leg would be the one that's right next to that angle, but not the hypotenuse, because hypotenuse is the case. So hypotenuse, opposite, and adjacent. We got to be quick with that. You feeling okay with that part at least? Yes, yes. All right, then from there, we need to choose our trig function. I noticed in this problem, we have information about the hypotenuse and the opposite. So I go up to my little SOHCAHTOA and I ask myself which one of these has opposite and hypotenuse in it. And it's the one with the S, right? So that means we're going to write a sine equation. Trig equations always look the same, right triangle trig equations anyways. You got sine, cosine, or tangent. Inside of that is your angle. In this case, that's 4.85. And then here and here, you got two sides. And those sides are determined by your SOHCAHTOA. So since we're doing sine, it should be opposite on the top, hypotenuse on the bottom, OH. So opposite on the top, hypotenuse on the bottom, and there we got our equation. Can you guys show me on your little thumb meters how familiar this is to you right now? All right, thank you for your honesty. If you're in this range, you got some work to do. Okay, we're gonna practice them today. Ask some good questions, but you may need to do a little self-practice on this, and you'll be doing a bunch of it your home. And it'll be your last year, yeah. But it wasn't for very long. Like the big introduction was in geometry, and again, you know, that was a weird year. So, all right, so let me rewrite this. So we're in the new version. You guys do know for sure that this is not multiplication, right? This is a function, and this is the input that's going into it. So we cannot separate these two things, but that's okay. We don't need to anyways. We just need to get rid of this 0.5. That should be pretty easy. We'll multiply by 25 on both sides. And then we reach for our calculator and we type it in. We do need to start being conscious of the mode that our calculator is in. So I'd like you guys to get in the habit before you ever do anything with sine, cosine, or tangent. Tap your mode button. You guys all have your calculators out. And third or fourth line down, you should see an option between degrees or radians. You want to get in the habit of doing this every time you use your calculator, because we're going to be switching back and forth a bunch. If you're in the wrong mode, you're going to get the wrong answer. This is in degrees. This angle measure was in degrees. So I'm going to make sure I'm in degree mode, which I am. Quit out of that, and then just type in 25. That's good. You need my x value. And is that my final answer? I'm gonna have to go back to the problem again. Right, because that was just this piece of it, we need the full distance, so we'll double that to get about 4.23 statute miles. Does that sound correct? So a little bit. I multiplied it by 2 because when I made this right, I was looking for this whole distance, but when I made my right triangle here, I cut it. So this x was not the full distance, it was only half of the distance. We wanted the full distance. So we did times 2. All right, any other questions from homework? Questions. We're going to start with trig, and then we're going to go, or we're going to start with right triangle trig, and then we're going to go into some other stuff in a minute here. Time permitting, I will check your homework. If not, hang on and we'll get it next time.